Let us start with dark matter, because this is where the theory gets truly mind-bending. Dark matter is the single biggest mystery in modern physics. We know it exists because we can see its gravitational effects. Galaxies rotate faster than they should. Clusters of galaxies hold together more tightly than visible matter can explain. And the large-scale structure of the universe only makes sense if there is roughly 5 times more invisible matter than visible matter out there. But nobody has ever detected a dark matter particle. Not once. Despite decades of experiments, particle colliders, deep underground detectors, and space-based observatories, the search has come up empty. Every candidate, WIMPs, axions, sterile neutrinos, has either been ruled out or remains unconfirmed. The QMM theory offers a completely different explanation. What if dark matter is not a particle at all? What if what we are detecting is not missing mass, but the gravitational weight of accumulated information? Here is how it works. Every time something happens in the universe, a star explodes, particles collide, light passes through a region of space, the event leaves an imprint in the space-time cells of that region. Over billions of years, these imprints accumulate. They add up. And because information has physical reality, a principle first proposed by physicist Rolf Landauer in the 1960s, these accumulated imprints have gravitational effects. They curve space-time, just like mass does. If you are finding this mind-blowing, subscribe to the Odd Vault and hit the bell, because what comes next connects dark energy to the same idea. The QMM theory also provides an explanation for dark energy, the mysterious force that is causing the universe to expand at an accelerating rate. Dark energy makes up roughly 68% of the total energy content of the universe, and nobody knows what it is. The QMM explanation is elegant. Each space-time cell has a finite capacity for information. It can only store so many quantum imprints before it is full. When a cell reaches saturation, it can no longer record new independent information. Instead, it contributes a tiny residual energy to the surrounding space-time. When you add up this residual energy across all the saturated cells in the universe, it produces a background pressure, a force that pushes space-time apart. The mathematical form of this residual energy matches exactly the cosmological constant, the term Einstein added to his equations to describe a force that opposes gravity, the same term that modern cosmologists use to describe dark energy. Dark matter and dark energy, according to this theory, are two sides of the same coin. One is the gravitational weight of cosmic memory. The other is the energy released when that memory reaches capacity. And then there are black holes. The black hole information paradox has haunted physics for decades. When something falls into a black hole, it appears to be destroyed, crushed into a singularity where all information is lost. But quantum mechanics says information can never be truly destroyed. It must go somewhere. This contradiction between general relativity and quantum mechanics is one of the deepest unsolved problems in theoretical physics. Stephen Hawking spent decades wrestling with it. The QMM offers a resolution. If space-time itself stores information, then when matter falls into a black hole, its information is not destroyed. It is recorded, imprinted into the space-time cells at and around the event horizon. The information is not inside the black hole. It is written on the surface of space-time itself, like text on the pages of a book. This aligns remarkably well with the holographic principle, a concept proposed by physicists Gerard 't Hooft and Leonard Susskind, which suggests that all the information contained within a volume of space can be described by information encoded on its boundary. The QMM extends this idea by proposing that every region of spacetime, not just black hole horizons, records information on its boundaries. The entire universe becomes a holographic memory bank. But perhaps the most profound implication of the theory is philosophical. If the universe records every event that has ever occurred, then in a very real sense, nothing is ever truly lost. Every star that has ever burned, every planet that has ever formed, every particle that has ever collided, all of it is still written in the fabric of space-time. The universe is not just a place where things happen. It is a place that remembers everything that has ever happened. The past is not gone. It is encoded in the geometry of space itself. Florian Neukart himself stated it best. He said, "The universe may not only be geometry and energy, it is also memory. And in that memory, every moment of cosmic history may still be written." We look at the night sky and see darkness between the stars. But according to this theory, that darkness is not empty. It is full, saturated with the memory of everything that has ever happened since the beginning of time. The universe is a library, and we are only now learning how to read it. This has been The Odd Vault. If this unlocked something in your mind, subscribe, because we open a new vault every week. What they didn't tell you, we will. What if the universe has memory? A 2026 theory proposes that spacetime is not smooth. It is made of tiny cells, and each cell records a quantum imprint of everything that passes through it, every particle, every explosion, every photon of light, since the Big Bang. The universe is literally recording its own history. And here is why that matters. Dark matter, the biggest mystery in physics, might not be a particle at all. It might be the gravitational weight of 13.8 billion years of accumulated cosmic memories. Dark energy? The pressure created when space-time cells are full and cannot record anymore. Black holes? They do not destroy information. They write it on the surface of space-time. One theory, three solved mysteries. The universe is not just expanding, it is remembering. Watch the full story, link above. Subscribe to The Odd Vault.